Okay, good morning or afternoon, ladies and gents. So for our third lesson today, we're going to be building on what we've worked on with polar form vectors, and we're going to be using something called scalar multiplication. Now, I quickly touched on this a little bit earlier in our very first lesson, where we worked on certain things that would not be considered something based in vectors. This is part of the scalar. So for today's lesson, what we're trying to do is understand how we can find the scalar product of a number and a vector. Now remember, scalar is a non-vector value. So this means that the multiplication of a vector by a real number changes the length. So effectively, if you've got a vector of u and you double it, it is going to become twice the length. Guys, you're going to note in our first one or two examples, I've not made the attempt to try and draw our vector up. You're going to see one key thing here that causes a little bit of drama. So let's go with the first one here. So with example 1, find the scalar product of the following vectors in Cartesian form. So for this one, we know Cartesian form's got to be x, y in one of its 3 different styles. So we're trying to find 3v if the vector v is represented to -3. Well, for this one, guys, it's quite simple. We want to multiply this vector by 3. Therefore, we multiply both our x and y values by 3, and it gives the answer as 6, -9. Simple enough. Respectively, if we wanted to find half of a vector, in this case, if our vector is represented as -i minus 5j, if we wanted to find a negative half of this vector, we would then have to multiply -half into both of these values. -half times a negative, they become a positive, so this becomes 1.5i plus, or 0.5i, depending on what your phrasing is there, plus 5/2j. You're going to see I've also put these in decimal formation. Because there is nothing based in this question about leaving these as fractions, including improper fractions or decimals, either answer would be sufficient. Next part's where you're going to see the drama. Calculate the scalar product of the following vectors in polar form. So for our first one, I'm just going to fix this little part up here. If the vector u is represented by a magnitude of 3 at an angle of 120 degrees, we want to try and find 4u. You would think what we've done up here, where we multiply our x and y coordinates, or x and y components, we'd multiply both our magnitude and angle. But this isn't the case. The only thing we want to do here is multiply our magnitude. And I'm going to draw it up just over here for a moment. If you've got your Cartesian and you've got it at a magnitude of 3 at 120 degrees, if we're just multiplying this vector out, we're just increasing the size. It's just going to keep on going up and up and up. It's going to keep on going up and up and up. Are we changing anything about the angle? No. So in this case, because we've got a positive value we're multiplying it by, here this one, instead of just multiplying both sides where it could become some silly number, I have no idea why I've chosen to re-include it here. Don't ask. I have no idea. You can blame the coffee for this one here. Our answer would have to be 4 times the magnitude of 120 degrees. 4 times 3 is 12, 120 degrees. But it does have 1 or 2 minor changes. Let's show it for v here. If v is represented with a magnitude of 3 at an angle -40 degrees, so I'm just going to draw this one up because I haven't. Vector of 3 at negative 40. So it goes down 3, 40 degrees here. Find 1/3 of v. Because we're multiplying our vector by a positive scalar, we are not changing anything with relation to the angle. We are just changing the actual length of v. So for this one, it is just going to be 1/3 times 3 at a negative 40 degree angle. 3 over 3, 1. This is where it gets a bit trickier. Just give me 1 second, guys. Hopefully this is still recording. If not, I promise you I will redo this video up for everyone. If we have a vector represented with a magnitude of 4 at 80 degrees, in this case, we want to multiply it by negative 2. Because the direction of our vector is changing, the angle needs to be reversed. Doesn't have to be a significant change. We are just reversing it. So in this case, 4 at 80 degrees, if that's a positive vector, that means a negative vector would still be 4, but instead of going at 40 degrees, we would have to add an extra 180 degrees onto it, 260 degrees. Sorry, 220 degrees. Oh no, 260, my apologies. So for this case, what we need to do is we need to go negative 2 of a vector. We multiply our magnitude, negative 2 times 4. And in this case, we need to either add or subtract 180 degrees. In this case, we're going to be adding it here. So for this one, you could write it, because we're looking at our positive value, as negative 8 at positive 260 degrees all the way around. There is an alternative way of writing, which would still give you a full mark. This is positive. That's negative. You could also link it as magnitude of negative 4 at negative degrees here. 360, take 2. 260, negative 100 degrees. I would suggest at the moment stick with this one, guys, because you're just going off the main point, but it's entirely up to you. Third and final one here before we finish up. Or sorry, fourth final one. If we have a vector which has a magnitude of 12 at negative 120 degrees, find a negative quarter of this vector. Now we already know that if it's going in our direction and we want to find the negative direction, it's going to go in the opposite way, and therefore we will be adding or subtracting 180 degrees to our angle. So we multiply our magnitude. Negative quarter times 12, that becomes negative 3. Negative 120 degrees plus or minus 180. In this case, we're going to be adding it. So negative 120 plus 180 brings us to 60 degrees. The effective rule for this one, guys, if U has a magnitude in the direction with a specific angle, the negative U must be the exact opposite with an angle increase of 180 degrees. That's all it is here. So guys, I'll let you get on to your work. Good luck, and I'll see you on the next one.